Hello friends, today I am going to teach you Cohen-Sutherland line subdivision clipping algorithm. This is the one of the oldest and most popular line clipping algorithm. This is the oldest and most popular line clipping algorithm. It is developed by Dan Cohen and Ivan Sutherland. Ivan Sutherland. That's why it's called as Cohen-Sutherland line clipping algorithm. To speed up the processing, this algorithm performs initial tests that reduce the number of intersections that must be calculated. This algorithm uses a 4-digit code to indicate which of 9 regions contain the endpoint of line. This algorithm uses 4-digit code, or you can say bit code. 4-digit bit code like 000 like this, and 9 region and 9 regions that contain the endpoint of line, For example, we have 9 regions like this, and we have to write bit code for every regions. We can say 9 region and 9 bit code. For this is our window. So in window it will be 4-bit code like 0000. Second is 0001, that is a left corner, right corner 0010, then top 100, then bottom 0100, left corner 1001, 1010. Similarly 0101 and 0110. Now how this 4-bit code for 9 region work, let's see by example. First of all, these 4-bit code are called region code. This 4-bit code is also called region code, or you can also say that is a out codes. This code identifies the location of the point relative to boundaries of the clipping rectangle. Boundaries of the clipping rectangle is shown in this figure. Each bit position in the region code is used to indicate one of the 4 relative coordinate position of the point with respect to the clipping window. Means we have 4 positions of the point with respect to the clipping window, that is first top to the left, then right, then top and bottom. The rightmost bit is the first bit and the bits are stepped to 1 based on the following scheme. Means first set bit 1. Set bit 1. If endpoint A to left of the window, means this one is our window and first bit set to left of the window, that is 0 0 1. What is set bit 1? If the endpoints to the left of the window. Second, set bit 2. If the endpoint is to the right of the window. If the endpoints to the right of the window. Right of the window means this one. Right of window, this one is our window and the endpoints to the right of the window. Set bit 3. If the endpoint is below the window. If the endpoints to the below of the window, means third point, that is below this one. This is our third bit code. Now set bit 4, that is if the endpoints to the above of the window, above of the window, that is our top code, right? This way we can set the 4-bit code of 9 regions. First of all, we have to go through the left from window, this one, then right to the window, then below the window, then above the window, and what will be the 5th region, that is we have to repeat from left to right and above to below. So 5th region is this left corner of top, then right corner. So this will be our 6th region, and then 7, 8, and this one is our 9th region. For example, we have to set this bit to the 0. Why we have to set bit to the 0? Because if all bit code is 0 0 0, then we can say that this line is in the window. This line point is in the window. This way Cohen-Sutherland works. Now there is some conditions. First condition is, once we have established region code for all the line endpoints, we can determine which line are completely inside the clipping window. And which are clearly outside and which are clearly outside. So once we have established region code, and that we have to check whether the line clipping window is inside or outside. And how we will check this? For this, suppose endpoints are 0 0 0, means it is all about 0, then we can say that point is in the window, otherwise it will be outside. Now next one is another method to test the lines, that is total clipping equivalent to the logical AND operator. Method is test 2. For total clipping, what is total clipping? Suppose we have this window and one line is over here, P1, point P1 and P2, right? So we have to make this 9 region first, and we have to check this endpoints. We have to check this endpoints, and we have to find region code, sorry, not region code, but 4-digit code, that is for P1 and P2. Now what is the point for P1? What is the point for P1? It is in, look at that figure, point is in the left corner, right? So first we have to give one number over here because it is in left corner, all other zeros. It works like this is in the left corner, that's why 1, and then right is 0 because this point is in not right side, it is in left side, that's why here 0. And then we have to perform below. So below is 0 because it is in middle point, and it is also not in above, that's why it's 0. So we have to follow this LRBA from left to right, and make this all regions. So what is the point of P1? 0 0 0 1. And what will be the point of P2? This one is which region? Is the fourth one, right? So we have 0 0 0 and 1 code. How it will be 0 0 and 1? For it is in left corner, no, that's why it's 0. It is in right corner, no, that's why it's 0. Now it is in below, no, 0. It is in above, that's why 1 0 0 0 point of P2 will be declared, right? So P2 is equal to 1 0 0 0. And what is the total clipping? What is the total clipping? Is equal to, we have to make logical AND operation with two endpoints, right? Means we have to give this 0 0 0 1 plus 1 0 0 operations, and this point is not to 0 0 0 0. The line is completely outside the clipping region, right? And for example, the line that cannot be identified as a completely inside or completely outside a clipping window, by this test are checked for interaction with the window boundaries. Now let us consider one example of Cohen-Sutherland. For example, we have this window, right? And we have points of line, first line, that is P1, P2, P3, P4, P5 and P6, P7 and P8, P9 and P10, P9 and P10. This is supposed to be given in example, right? So what we have to find? We have to find the region code for each endpoint and identify whether the line is completely visible, partially visible or completely invisible. For this figure shows clipping window and lines with the region code. This code are tabulate and point codes are logically ANDed to identify the visibility of the line. So let us make regions. Let us make 9 regions. Like this, we have to make 9 regions, right? This one is first region, first region should be 0, 0, 0, 1. Second 0, 0, 1, 0. Third 0, 1, 0, 0. Fourth one is 1, 0, 0, 0. Fifth 1, 0, 0, 1, 1, 0, 1, 0, 0, 1, 0, 1 and 0, 1, 1, 0. And this will be our window. So in this region all code are 0 because this is our window. So let's check. First line P1 and P2 are inside or outside. So we have to make one table, that is line endpoint codes, then logical ending and result. So we have to make this table and check one by one line whether it is inside or outside. So first line, that is P1 and P2. Now P1 and P2 both are in his window. So P1 is equal to 0, 0, 0, 0 and P2 is equal to 0, 0, 0. And what is the logical ending operation? That is also 0, 0, 0. So we can see that the line is completely visible. Clear? Now similarly this way we have to check out for P3, P4, P5, P6, P7, P8 and P9 and P10. Now checking the second line P3 and P4. Now P3 is in left corner and P4 is also in left corner. So P3 and P4 value is 0, 0, 0, 1, 0, 0, 0, 1. And what will be the logical ending operation? That is 0, 0, 1. So we can say that this is not 0. So line is invisible. So line is invisible. Now similarly this way find the value of P5 and P6. Now P5 value, that is in our first quadrant 0, 0, 0, 1 and P6 is in window. So P6 value is 0, 0, 0. Now perform the logical AND operation. It will be give 0, 0, 0. Right? So this is partially invisible. This is partially invisible. Why it is partially invisible? Because P5 is partially invisible and P6 point are visible. That's why it's called as partially invisible. Now similarly P7 and P8, it is 0, 1, 0, 0, 0, 0, 1, 0 and operation of them 0, 0, 0. so it is also partially visible, P9 and P10. Now check for P9 and P10. It is in above region, so this value is 100 and P10 is 0010. What are the AND operator and what will be the answer? That is 0. That's why it is completely visible. Now clear how we take the line clipping algorithm. Suppose value is 0, then it is completely inside this window, and if value is not to be 0, it will be the outside of the window. Clear? This way we can use the clipping algorithm. Now we can see that suppose this line P1 and P2. Suppose this line P1 and P2. So let's make one diagram and draw the line P1 and P2. Suppose this point P1 and P2, right? So it may be in different region, that is a left region and above region. So this point of P1 and P2 will be clipping by P1 dash and P2 dash as shown in figure. Now what will be the intersection point found, and we get two line segment, that is two line segment, that is P1 minus P1 dash and P2 minus P1 minus P1 dash and P1 dash minus P2. We know that for P1 and P1 dash, one end point, that is P1 is outside the window, and thus the line segment P1 minus P1 dash is discarded. Clear? Now reduce the section from P1 to P2. Since P2 is outside the clip window, it is checked against the boundaries and intersection point P2 dash is found. Again the line segment is divided into two line segment, that is given in P1 dash minus P2 dash and P2 dash minus P2. We know that the P2 dash minus P2, one end point, that is P2 is completely outside the window, then thus the line segment P2 dash minus P2 is discarded. The remaining line segment P1 dash minus P2 dash is completely inside the window, inside the clipping window, hence made it visible. Now the interaction point with the clipping boundary can be calculated using slope intersection line equation, that is the equation for line passing through point P1 x1 comma y1 and P2 x2 comma y2 is y is equal to m x minus x1 plus y1, that is our slope equation. Y is equal to mx plus c. So consider x value as x minus x2 and y2. It will be constant, where m is equal to y2 minus y1 divided by x2 minus x1. This is the slope of line. Therefore, the intersection with the clipping boundaries, therefore, the intersections with the clipping boundaries of the windows are given as, first of all, we make the equation for left, that is xl comma y is equal to m xl minus x1 plus y1. M is not equal to infinite. Similarly, right corner, that is xr comma y is equal to m xr minus x1 plus y1. M is not equal to infinite. Now for top, that is yt x is equal to x1 plus 1 upon m yt minus y1. M is not equal to 0. Similarly, we have bottom equation, that is yb comma x is equal to x1 plus 1 upon m yb minus y1, the m is equal to 0. This way we can solve the Sutherland subdivision line clipping algorithm. We have to subdivide this intersection points. That why is called Sutherland Cohen subdivision line clipping algorithm. Now, algorithms for what are the Sutherland and Cohen subdivision algorithm. Line clipping algorithm. This algorithm is most important for GTU exam. It will be covered 7 marks. It will be asked in 7 marks. So this is most important. Now what are the steps of algorithm? First step, step number 1, that is read 2 endpoints of the line, say P1, that is point 1, x1, y1, and P2, x2, y2. Now step number 2 is read 2 corners, that is left to top and right to bottom of the window, say window x1 comma window y1 and window x2 comma window y2. From this window, this is our point P1 and this is our point P2. and this point will be wx1, wy1, and this point will be wx2 and wy2, right. Now step number 3, what will be the step number 3? That is, assign the region code for two endpoints P1 and P2. Assign the region code for two endpoints P1 and P2 using following steps. Initialize code with, we have to initialize code with bits 0 0 0. Now set bit 1 if x is less than wx1. Set bit 2, that is if x is greater than wx2. Set bit 3, that is if y is less than wy2, and set bit 4 if y is greater than wy1. Now step number 4, check for visibility of line. Check for visibility of line P1 and P2. In this, how we check the visibility of line P1 and P2? First we have to check if region code for both endpoints P1 and P2 is 0. Region code are 0. Then the line is completely visible. Hence draw the line, draw the lines and go to step 9 and go to step 9. Step 9 will be stop, right. Now second way, if region code for endpoints, if region codes for endpoints are not 0, and the logical ending of them is also non-zero, then the line is completely invisible. Then the line is completely invisible. Got it? So reject the line and go to step 9. So reject the line and go to step number 9. Now there is a third condition, if region code for two endpoints does not satisfy the condition, if region code for two endpoints does not satisfy the conditions of this A and B. A and B. Then it is partially, then the line is partially visible. Now step number 5. After this, step number 5, that is the determine the intersecting edge of the clipping window by inspecting the region code of two endpoints. What we have to do in step number 5, that is determine the intersecting edge of the clipping window by intersecting the region codes of two endpoints. First is if region code for both endpoints are non-zero. Both endpoints are non-zero. Then find intersection points P1 dash and P2 dash with boundary edges of clipping window with respect to point P1 and point P2 respectively. If region code for any one endpoint is non-zero, then the find intersection point P1 dash or P2 dash with boundary edges of the clipping window with respect to point 1 with respect to point P1 dash or P2 dash, right? Now what will be step number 6, that is divide the line segment considering intersection points. Divide the line segment considering intersection point. Step number 7, that is reject the line segment if any one endpoint of it appears outside the clipping window. Step number 8, draw the remaining line segment and step number 9, that is stop. This is the algorithm of Sutherland and Cohen subdivision line clipping algorithm. There are 9 steps, and similarly you have to solve this example of Cohen-Sutherland subdivision algorithm. I hope you clear with this concept of Cohen-Sutherland line clipping algorithm. For that, we have to make 4-bit codes and 9 regions. All of the 9 regions are working in left, right, then above and below conditions. This way we can solve this Cohen-Sutherland line subdivision algorithm. Thank you for watching this video. I hope you clear with Cohen-Sutherland line subdivision clipping algorithm.